Hello everyone. Today's session we are going to see about uh, in the embedded real-time system, which is nothing but ARM7 architecture. So this is a generic architecture which is for 32 bit. So as you all know that architecture is the building block of how the data or instruction is getting in and how it is getting processed. This is a simplified architecture where you will have a 32 bit ALU as shown in the figure. Right. So basically the processor needs the instruction which will be available in the memory only. So what is the processor needs to do here? First it has to issue the address. So the bottommost part has the address register which will provide the initial address, say 0. So this address will be fetching the instruction from the 0th address. So it will come in through the instruction decoder which is available in the topmost area, where the instruction will be getting decoded, and after getting decoded the control unit will enable accordingly the blocks which has to work for the instruction. So the upon the instruction or the command from the control blocks, the data which is also available either in the memory which or from the input output devices will be getting in, and it will be getting stored into the register file. So it is in the center area where you can find the numbers given as R0 to R15. So which means we have 16 general purpose registers which is to provide data to the ALU and to load and to store the result out of the ALU. So basically here there are two leads which are coming out from the register file, which is called as A, another is called as B. So which means A is the primary register through which the ALU is getting the data directly, whereas the other data is being passed through barrel shifter. Barrel shifter is nothing a serial in serial out kind of input. So whereas you will get the data shifted in through the barrel shifter into the ALU, and after computation the data is getting stored into the register file through the feedback path like arrangement, what is coming out of ALU and it is getting back to a register file through RD. So here the another unit what is called as multiply and accumulate, which is to multiply and accumulate. That is mainly for multiplication process, where we can see there are three leads coming out from A, B, C and mainly from accumulator. So after which those data are also getting stored into the rest file. So this is there is one more block available at the top end, what is called sign extend. So sign is to negate whether it is a positive or negative commands. So this is the ARM architecture's future. So ARM architecture has a program status what is called as the which will respond to the ALU's operation. So after every operation, what is the output that was produced by the ALU? So here we have a series of sequence of flags, and few are listed here such as 0, sign, overflow and a carry flag. So mostly every processor will have such program status word. Similarly ARM also has. Then there is a priority encoder. So this is used while multiple load store instructions are utilized, and and also to point which register within the register will to be loaded or stored. So based on the priority which is being issued, the register will be getting loaded or stored. And there is availability of multiplexer which is to manage the processor bus, because without this the processor bus cannot be engaged efficiently. And as far as the ALU is being concerned, it has two 32-bit input, as we saw there, which has ALU is getting two leads through A and B. So through A we are getting a 32-bit input, and through B we are getting another 32-bit input. So these two gets into, and as I said, the primary will be coming from register file, other from the barrel shifter. So here it is clearly given for multiply accumulate we are using both multiplier, and it has 3 32-bit input, and the results is getting returned into the register file. So barrel shifter, so it is to shift the 32-bit input from the register file or immediate data into the ALU. That's all. So control unit is to provide control. So accordingly the instruction being provided from the memory or the application developer, whatever being given. So incremented operation is for when the first address being fetched, we need to increment the address number. So we are in need of this incrementer. So upon the incrementation, see the next address will be getting updated, so that we may load the instruction, or we may store the data to those locations. And then comes the address register. So its major purpose is to initiate the memory for releasing the instruction from which memory location exactly. So the next is instruction decoder. This is to decode the instruction and generates the opcode, and upon which the control blocks will get initiated. Finally, register file, a bank of 32-bit registers over here, and as I said, it ranges from R0 to R15. Totally 16 registers are there. It is used to store data items. So ARM Cortex comes with three profile. One is called as A profile, another is called as R profile, and the final one is called as M profile. So A means application profile, R means real-time profile, M means microcontroller profile. So as the name implicates here, according to the application, you can choose whichever profile you are in need of. So if you go with the application, you go with A. If you want to perform real-time operations, go with R. Or you want to only control some application, then you go with microcontroller profile. See, and the application profile, it has two kinds of registers, either 32-bit or 64-bit registers, whereas R profile uses only 32-bit registers, whereas M also uses only 32-bit. Whereas according to the instruction set is concerned, as we say earlier, in the register category, it has ARM 32-bit mode as well as ARM 64-bit mode, and whereas since it has got two modes, we are supposed to have thumb instruction mode also. So it supports T32, which means thumb instruction mode. Whereas looking at R profile, we have ARM 32-bit and thumb 32-bit instruction set mode only, and in the M profile we don't have ARM, we only available with thumb instruction mode. Looking at the memory support, we have virtual memory support in A profile, protected memory support in R profile, and only the same protected memory support is available in M profile also. So looking at the real-time OS, A profile R profile supports real-time OS, whereas M profile does not support real-time OS. And A profile can be used in mobile phones, and R profile can be utilized in critical applications, say anti-braking system, and M profile for control application. As I said, we can choose any industrial control application. Whether I am ending this ARM architecture session. Thank you for watching. Thank you.